Okay, so my name is Uendi Hoxha. I'm a DevOps engineer, and as you can guess here, I have a passion for cybersecurity, especially for cloud security. And today we're going to discuss about machine learning and how to build a secure one in Amazon SageMaker. So first, I want you guys to imagine this. Let's say that you have just built an amazing machine learning model that's potentially gonna revolutionize your business, or it's a nice model you want to sell, or I don't know, something you're researching for a PhD and stuff like that. And we get the trend, creating a machine learning model. Very nice model. Okay, but there is something we should keep in mind, which is how secure is your machine learning model? And this is something that's not always considered 100%. And that's why we're going to discuss together how we can build a machine learning model in Amazon SageMaker that's your project not going to be only efficient, but also secure. We don't want to have those unauthorized access that everyone just talked about, destroying our brilliant ideas. So, of course, we have to firstly understand the importance of security in machine learning. As all of us that we are here, we understand the importance of security in our projects. Because I see security as, I'm going to take an example, as a house, you can have a very beautiful, well-designed house, but if your house does not have strong walls, that you don't even have to wait for an earthquake to happen, because it's just gonna collapse anytime soon. So the same thing applies for security in machine learning. And in machine learning is more delicate because, for example, we might have a healthcare company that uses machine learning model to predict clients' diagnosis based on medical data. So what will happen if someone is gonna get access to somewhere he should not, and let's say predict how the model expects the pattern of the input? First, privacy violation 100%, and probably legal issues here. But most importantly, if someone with unauthorized access can understand the pattern of the input, then it will result in invalid diagnosis, right? They can manipulate the diagnosis, and we don't have a trustworthy system anymore. Thus, probably financial damages for even the company, but also for the client, and possibly it might be dangerous because the client might even die. So there are challenges in security in machine learning, especially in cloud. It comes with lots of benefits, but it has its own challenges. So first is data privacy. Protecting sensitive data sets from leaks or unauthorized assets. Later on, we're going to see a flow of building a machine learning in SageMaker, and we're going to understand that data sets, it's a very important part of building it. Data sets contain very sensitive information that we don't want to get leaked. Then we have model integrity, so ensuring that the model hasn't been tampered with during training or deployment. Training and deployment are both two very important processes when creating a machine learning model in SageMaker. We're going to see it later on in details. And also access control, something that was mentioned a couple of times during this conference. So managing who can interact with your data and models. And here I don't only mean people, which is of course important because it's like giving your aunt, nothing personal with the aunties here, but giving your aunt the keys of your house. She doesn't have to have the keys of your house, even though she's not gonna do anything with it. So, but here I also mean managing data within your project, within the components of your projects, which we're gonna see later on. So here is a more generate example data, how the data is being processed, and the steps that it follows in machine learning. So The fetch, clean, and prepare is the process when the data comes, when it's still in storage. In SageMaker, we store the data in a service called S3 buckets. So here we just like take the data, we clean, we analyze it and stuff like that. And then we prepare the data to create the model. Then we evaluate the model and we prepare it to deploy in production or whatever you want it. And then we have the monitoring, collecting data, and everything goes on and on. We should understand that the security risk is in every phase of this one. Like the security risk can even be when your data is like stored somewhere. Someone can take advantage of like the security issues you're having in your storage and can take advantage of it. This is a more in detail, but later on we're going to see a more detailed one, schema of how the machine learning model in SageMaker is working. So here we can see that we have two different clients. One has a direct invocation to the SageMaker endpoint. In SageMaker, the model is deployed into an endpoint. So straightforward to the endpoint, and then we have the model which is deployed to the endpoint, as I just said. Then we have another client, which actually is using another service, which is API Gateway. And then it will go straight to the endpoint. Here we also have AWS Nitro Enclaves, which is a service. We don't have to go much deeper into details into it, but we have to understand that this service is used to isolate a part of the model or something that you want to isolate within your project. And later on, we're going to see why that's important. So here we can make the connection at what I just said earlier, that we have the case in which our model is interacting with another service, which in case is API Gateway. So what should we do into the scenarios here? So here we have how the model is created in SageMaker. So we are creating an instance, which in SageMaker is called a notebook. After creating the instance, we then like store the data somewhere, as mentioned before, and we create the model, which is the algorithm, the patterns that we want to use for our machine learning project. After the model is ready, and what do we mean with ready? We will see. We deploy to a SageMaker endpoint. And here we can see the walkthrough of the data until it goes to the client. We can see that we have an encrypted result and it goes to the client. We can see that the client uses a private key to decrypt the data that comes from the model. And the same thing goes here. So we can understand that the client is the only one who can see the decrypted data using its private key. And this means that the data is encrypted starting from the scratch. So starting from, after creating the notebook instance, it is stored, creating the model, etc. So this is a more in detail schema. So training the data set. We have the data in S3 buckets stored. We are analyzing, probably experimenting with it until we make sure that's the data we want. Then we store to S3 bucket, which is encrypted, starting from them. Then we are using SageMaker to create the model. Then we are pushing to the endpoint. So here we can see the link that the data is encrypted, even when the client sends the data to the model. Here we can also see the reverse side of what I just explained. So we have the data being encrypted from S3 to the client. So we also have to mention some security features that might be basic, but I've had cases in which personally I've been asked, just give him the access, like he's not gonna do anything, right? which I personally don't think it's a good practice. Everyone should have at least privileges as possible, and no one should have access to everything. So, we have the access control, which, as mentioned, I think, by Daniel. He gave a very good explanation of how IAM service functions in AWS, which we use roles and policies to assign to the user. So we have two possibilities here. You can either create a role of yourself, like create a custom role or policy that you want, or you can use policies that are already created and managed by AWS. So it's just a matter of choice depending on like the infrastructure that you're going to build. Then we have encryption, which in Amazon SageMaker goes in two phases. So at first we have at-rest encryption. Here, SageMaker is using KMS, which is a service to create keys, and they are used to encrypt data in S3 buckets or ABS volumes. Then we have the data in transit, where data moving between different components are encrypted using TLS. Next, we have network isolation. So it's very important to isolate your project or even components within your project so that, let's say, if someone is attacking a part of it, not all of it is going to fall down. So in this case, we can use VPCs, and we can use security groups there, in which is a set of inbound and outbound rules. So you can define the range of IPs or services that you want to access your model. And then you can also use access control lists, as per usual. So you want to keep training jobs, endpoints, and other resources out of the public internet. And next we have secure deployment. So after everything is like done, of course, we don't want to mess at the last step, which is deployment. So we need to keep that level of protection also there. So in this case, we have encrypted endpoints, which makes sure that the data flowing in and out that are deployed are secured and protected. Then we have access control on endpoints, in which you can configure your endpoint to receive access from whatever you want. Let's say that someone is attacking your endpoint and you're gonna, it's gonna say, okay, I'm receiving requests from here. Am I expecting to get that request? If yes, okay, walk through. If no, go away. So it's a pretty nice feature to have. And of course, some best practices for building a secure machine learning environment. Of course, apply least privileges access. So as mentioned, we must ensure that users have only the permissions that they need. This might sound very basic thing, but I've seen this as something that's really not considered that much as it should. And as a result, is like causing damages that might take time or even might not take time to solve. Encrypt everything. So that's the data that we want to protect. The data should be encrypted and protected at every phase of your machine learning model, so that no one can take advantage of your security issues. And yeah, we don't want to have problems there. Then we have regular audits. Of course, monitoring is a very important part of identifying the issues, and this is something also I've noticed is lacking. Sometimes we might just depend on daily monitorings or manual stuff, but it's very important to have as much things as you can being automated. This means creating alarms, not only when things are failing or you predict things that are going to fail, but also when things are like acting as usual. Like you might want to understand even the pattern of how your model is functioning, but also when there is an issue. It will be easier for you to identify why it is failing, what's causing this to fail, and stuff like that. So in AWS are a lot of nice services. One of them is CloudTrail. You can use CloudWatch or even AWS Glue for reporting, and also for reporting purposes. Then secure the entire machine learning pipeline. So we have to understand that security isn't just part of the process. So in this data-driven world, having a secure machine learning model is not a nice-to-have thing. It's a must-have thing. So secure your data, your training jobs, endpoints, and your overall infrastructure, so that we don't wanna get things messy. We don't wanna be repetitive of the issues that we are encountering in security. So you can see this schema where there are real-world examples of machine learning. We should understand that these are very dynamic industries, and it should be very important to follow best practices of security in cloud, and not only. So thank you for your attention. I try to keep it as short as possible so that everyone can enjoy. If you have any questions, you can reach out to me, or during lunch break maybe.